Okay, anybody else? Remember we drew them on the graph. Yeah.
This is just like how far away it is from the line.
It is. Remember how we drew them in? How far the point is away from the line? And so, residual, to find it, we are going to do the actual or observed minus the predicted, or the line. Now, if we actually have the points listed in a table, we can be super exact about that. If we don't have the points listed in a table, we are going to have to kind of draw the graph for that, and that's what we're going to do. Okay, here's the deal. We have not done a residual plot yet. We have done this, right, where we drew the lines in. Okay, here's what the deal is. I'm going to do one in a second. If I get the residual, how far they are off the line, and I get all of those numbers, and I put them on a plot like this, what happens is I get sometimes, hopefully, a random mishmash of points. If they're really, really random, what that tells me is a line is a good fit for the data. If they're not random, meaning like let's say I get something that has a nice pattern to it, what that means is, back from earlier on, I don't know if you remember this, I told you guys, you don't have to flip back, I'll just show you. I told you there were other models for data. We did linear. Do you remember there was nonlinear? Like I did some U stuff and some exponential stuff. Okay. And are we going to choose those? No. But what that tells you is the residual, if it has a pattern, what that means is those might be better models. We're not going to decide which one is, but we know that the line's not the best. So let's write two things down for a residual plot. One of two things could happen. If the residuals are scattered around the x-axis, a line is a good model for the data. So if they're scattered, a line is a good model for the data. If the residuals are patterned, a line is not a good model for the data. So if the residuals follow a pattern, then the line is not a good model. Okay, now here's the deal. It is really nice when I give you an equation, and in your homework today I'm going to give you a real basic equation. Here, I don't give you an equation, so this is what we're going to do. We're going to write down what the x value is, and then we're going to write down what the residual is. So I'm going to look and I'm going to see, hey, how far is the point from the line? Okay? Alright, so let's take a look at what we have here. Looks like we have a plot, and on the y-axis, to me, it looks like they're going up by ones, right? I mean, it's 5s, but each little tick mark is a 1. Like if I looked, it was 10, 11, 12, 13, 14, 15, okay? And then, do you see here, these are going up by 2s, but then they're cut in half and half again, so those are going up by like 0.5. Okay, so we ready? This point is how far below the line do you think? How many little tick marks? 2? So if it's below, we're going to write -2. And it looks like its x value is about at 2, doesn't it? Alright, let's take the next point. It looks to me like this one is at 3. How far above the line is it though? Like maybe a 1? So I'm going to say x value is 3, residual is 1. And I'm going to make this point, because it's a little further over, I'm going to make it be at 3.5. How far below the line does that look to you? Like -3 maybe? Okay, moving on to the next point. The next point's like right here. Does that look like 5.5 to you? And it looks like it's above the line, doesn't it? How far above the line is it? You want to call it 3? I'm going to call it 4. It just looks a little more than that one. Alright, then I'm going to call this point 6. And how far above do you think that is? 1? This is why it's not as accurate if you would have an exact equation, but we can figure it out. Alright, this looks to me again like 7.5, and it's below the line. You want to call that -1? And I'm going to call that 0.8. And what do you want to call that for the residual? Yeah. Alright, this point I will call 9, you want to call it 9.5-ish? And it's below the line, you want to call that -3 maybe? This one's above the line, oh crap, we'll call it 9.75 because it's not quite to 10. And how far above? Maybe a 2? And then I'll call this 10.5 and -2. Okay, so now this is how we make a residual plot. We take these residuals and we plot them on the y-axis. So let's label that. And on the x-axis, we graph the x value. So the x-axis is the same as the x goes up here. So would you plot those residuals for me? Some of them are going to go above the grid that I gave you. So just do the best you can. Alright, now you might have even noticed as you were plotting, what was happening as you were plotting the points? They were, like we were going above and then below. Very random, right? So using what I taught you up here, If the residuals are scattered, what does that tell me? A line is a good model for the data. So I am going to write a line is a good model for the data because the residuals are scattered around the x-axis. Okay. In the other hour, we went on to a long problem where we did a linear regression and we came up with the equation. I'm going to just kind of show you on your homework how that works with an equation because I want to make sure that we have time to go past that count, right? You guys remember I told you? Okay. Would you get out then, let's take a look at this